I will be explaining proposition 6, that is every interval is measurable. That is the statement. So what you are going to do is, in the proof, the first line what you are doing is, you are writing to prove every interval is measurable. Is that clear? That is what they are asking us to prove, right? So just write it down from the statement. That is to prove every interval of the form a comma infinitive is measurable. That is, in the statement they are saying us to prove every interval is measurable. Here in our proof, what you are going to do is, you will prove that you are selecting an interval, that is a comma infinitive, open interval a comma infinitive, and you are going to say this interval is measurable. Is that clear? Okay, now to prove that, what you are doing is, you are taking a set now, that is A. This set is any set, okay? Any one of the set you are taking, that is A, and there is a condition also. Within this set A, you should not have an element A. This A does not belongs to this A. That kind of set you have to choose. So here how you have to write in sentences, let A be any set that does not contains, let me look at my note. Where is that? Okay. Let A be any set and A doesn't belongs to A. That is what you have to write. Okay. Now after that, you are taking another two sets, that is A1 and A2, and you are saying A1 equal to intersection of A and minus infinitive comma A. It means, wait a minute, you are having an interval, no? Minus infinity to infinitive. Okay, I am putting the number line. A is present here. Imagine if A is here. So here A1 means what? A intersection minus infinitive comma A. Okay. A2 is A intersection A comma infinitive. Can you understand? That is how you are choosing A1 and A2. That is, the common elements present in A and this interval is denoted as A1, and the elements present in both A and A comma infinitive are denoted as A2. That is how you are taking all these things to prove every interval is measurable. Okay. So that is to prove, you are going to prove this m star of A greater than or equal to m star of A1 plus m star of A2. So our intention is to prove this. So to prove this, you need A1, A2, A, all these know, right? So that is why in the above steps you are taking a set A and you are writing what is A1, what is A2. Is that clear? Okay, to prove. Now, if m star of A, if the outer measure of A is infinitive, then there is nothing to prove. Okay, that is what you will write. If m star of A equal to infinitive means, then there is nothing to prove. If m star of A is finite, less than infinitive means what? You are finding the outer measure of capital A, the value will be finite. Okay, that is what the meaning of this. If the value is finite, then you are having so many things to write in that case. Okay, so here you have to write given epsilon. By the definition of outer measure, you are writing this 3 lines. Given epsilon greater than 0, there is a countable collection ik, k equal to 1 to infinitive, of open bounded interval containing A such that this that is, you are taking a countable collection of open bounded interval, that is this. Okay, and within this interval you are having A. You know that what is A? A means what? A is any set, no? So what is that? What you are writing within this ik, k equal to 1 to infinitive, that is within this open bounded interval, you are having A. That is what they are writing. Is a open bounded interval containing A. It means what? Within this you are having A. That is what they are saying. Such that write this. from the definition of outer measure. Now you are defining another two things, that is ik dash and ik double dash. Ik dash means intersection of ik and open interval minus infinitive comma a. Ik double dash means intersection of ik and open interval a comma infinitive. That is how you are defining. Also this ik dash and ik double dash are what? Intervals, and ik, when you add ik dash and ik double dash, you will get ik. Okay, that is how you are choosing, defining all these things. Now in the next line what you are writing is, since ik dash k equal to 1 to infinitive and ik dash k equal to 1 to infinitive are countable collection of open bounded intervals. You know that they are countable collection of open bounded intervals, because ik is a countable collection of open bounded intervals. No, so you are splitting ik like this. So then this also will be the collection of open bounded intervals. So that is what you are writing, that covers a1 and a2 respectively. Here this interval is covering a1 and this interval is covering a2. It means what? If you are having this interval ik dash, okay, ik dash covers a1, it means what? Within this ik dash you are having a. Ik dash covers a. This is what the meaning. Sorry, a1 no. a1 present inside this interval and a2 is present inside which interval? Ik double dash. Okay, so that is what they are saying here. Ik dash k equal to 1 to infinitive and ik double dash k equal to 1 to infinitive are countable collection of open bounded intervals that covers what? a1 and a2 respectively. Now they are covering, no? What covering? This interval is covering this and this interval is covering this. So what you can write? a1 for this interval and for this a1 you are going to write this. a1 contained in this, because this interval covering this, no. So in general, imagine what is called covering something. What is mean by covering something? I will show you an example. I am saying that I am covering this pen using what? Using a cover. What does it mean? I am putting this pencil within the cover, right? That is, this pencil will present inside it. That is what the meaning of cover, right? The same thing is here. Here this interval is covering a1 means what? a1 will be present. That is, a1 contained in this interval. Okay, that is what you are writing. a1 contained in union of these intervals. Okay. Now you are taking measure, outer measure on both sides, so that you will get m star of a1 less than or equal. Subset, no, a1 is subset, a1 contained in this union. So it means surely the outer measure, if you find the outer measure of this, that will be less than or equal to this. Because here you are having I1, I2, I3, I4, so many, I1 dash, I2 dash, so many, till infinite. Here you are having only one set A. And A1, and already you are saying that A1 contained in this. So obviously the measure of this E1 will be less than or equal to this. Okay, measure of this. So that's what you are writing. Now in the next line what you are doing is, this can be written like this. By using a proposition, you can write this like this. Okay, that is, you are bringing this union outside. When it comes to outside, it becomes summation, and then m star is coming next to it, and then ik dash. Okay, and then similar, the same thing you are writing for this interval and this a2. The same process. Mark it as equation number 1 and this as equation number 2. In the next line you will add it. Okay, you are adding equation 1 and equation 2. It's very simple. When you add it, you will get this. And this will be equal to what you are doing, you are taking summation k is equal to 1 to infinitive outside, so that you will get and write the remaining. And then m star of ik dash plus m star of ik double dash can be written like this, because you know that already I told you ik is splitted into two intervals, that is ik dash and ik double dash. So here this can be written like this. Now m star of ik can be written like L of ik, okay, by a proposition, by a definition. M star of something is equal to length of that something. So that is what the definition that you will learn in the beginning of the of this unit. So we are using that here. So you know that summation k is equal to 1 to infinitive L of ik value we are having already in the beginning. You have wrote it, no? So just you are substituting the value here so that you will get. Now write the left hand side and right hand side. The value of epsilon is arbitrary, okay? It's a small value, so that is why it's a constant value. So you are removing that. When you are removing that, you will get less than or equal to. It becomes like this. Now this can be written like this, right? And from this you can say you proved it, right? This is what our intention to prove, so you proved it. So therefore you can say a comma infinitive is measurable. If a comma infinitive is measurable means what you are trying to say, every interval is measurable, hence the proof.